And welcome back. Remember to start with your name and date. Today we're doing 3.2, rate of change and slope. This assignment will come from pages 65 to 70. Our essential question today is, how do you find a rate of change or a slope? We have some definitions to start with today. Rate of change. A ratio of the amount of change in the output to the amount of change in the input. Now this brings in two more words for us that you may not know. So very quickly, let's do output output is the value that comes out of the situation, also known as the Y. Input is our next one, the value put in, to the situation. Also known as the X. Example 1. Eve keeps a record of the number of lawns she has mowed and the money that she has earned. Tell whether the rates of change are constant or variable. So let's discuss constant. Does not change. If something is constant, then it always is. Variable is derived from the word vary, so it changes from one to the next. So, we're going to look at the information that Eve has kept track of on the number of lawns she has mowed and the money that she has earned. And we're going to look and see if the rates of change are constant, they don't change, or they're variable. It changes from one to the next. And we have to be careful with what we're talking about here. So let's look at her table. Okay, so day 1, she mowed one lawn and earned $15. Then on day 2, there were 3 lawns total for $45. 6 for $90 on day 3, 8 for $120 on day 4. So you always need to think about identifying your input and your output. And I will tell you, this is your input, this is your output. From there, we need to look at our rates of change. And it's just like we did yesterday. Not rates of changes, rates of change. Okay, if I look at day 1 to day 2, what I'm really wanting to look at is the change in the money over the change in the number of lawns. So from day 1 to day 2, in the money, I went from 45, or I need to find the difference of 45 minus 15, and 3 to 1. This is going to be 30, 3 to 1, not 2. 30 over 2, which is 15 over 1. If I look at day 2 going to day 3, then it's 90 minus 45 over 6 minus 3. That's 45 over 3, or 15 over 1. And last we have day 3 to day 4, which is 120 minus 90 over 8 minus 6. We have 30 over 2, which again is 15 over 1. So the rates of change are constant. They don't change. It's $15 per lawn. And I see that here where I reduce those changes and they all equal each other. They're all the same. Now you should have your book pages, and you need to look at, we're going to do another example here. There's a graph on page 66. Today I'm not going to sketch it, but what the graph does, at least I'm not going to sketch the whole graph. What I want to remind you about is you have to look at your graph. On this axis they're talking time. On this axis they're talking distance. And we have Nathan who bicycled. Okay. He bicycled over time. And we want to know what is Nathan's rate of change. And you're going to go and do the same thing that I just did on the previous example. We're going to use that graph and we're going to figure this out. So if we go from 1 hour to 2 hours, we're looking at distance over time, and that was 30 minus 15 over 2 minus 1, which is 15 over 1. The second hour to the third hour, again, it's still distance over time. I'll abbreviate it. Oh, sorry, I said 2 to 3 hours. What we need to do is 1 hour to 4 hours, and that would be 60 minus 15, 4 minus 1. That's 45 over 3, which reduces to 15 over 1 again. And we're going to do 2 hours to 4 hours now. Again, still distance over time. So 60 minus 30 over 4 minus 2. This is 30 over 2, which again, it reduces to 15 over 1. All of them were 15 over 1 when we reduced them. So my rate of change is constant. And the equation would then be y equals kx, in this case 15 over 1, or 15. That's my equation for Nathan's rate of change. Now this leads us into slope. So I have a definition for you. A ratio of the change in y values, We're going to call that the rise for a segment of the graph to the corresponding change in the x values. Or the run. Now I'm going to use a symbol here, so I'm going to put this over here. This symbol right here, the little triangle that I'm about to use, means and is read as change in. So if I'm talking about slope, I'm talking about the rise over the run. Another way to look at this is that it is the change in your y values over a change in your x values. Now Ms. Tutt also has a definition for this. It is how far up or down you go over how far to the right. Because I always connect slope to how we read. And we read from the left-hand side to the right-hand side. So when I look at my graphs, I'm going to start on the left-hand side, and I'm going to decide, going from one point to another point, am I going up to get there, or am I going down to get there? And then I'm always going to move to the right. This does some things, and as we get more into slope, I'll show it to you, but I use this quite a bit. Example 3, and I'm referring to a graph on page 67. Okay, I'm going to tell you to choose 2 points on that line. And then you're going to find the change in the y values and the change in the x values. Now, I looked at the graph and I chose a couple of points. I chose -3, 2 and -6, 4. I'm going to kind of sketch that in here so that I can show you a couple of things, and I don't guarantee how perfect it's going to be being sketched in. Okay. So I have my scale there. So -3, 2, I'm going to call that A, and -6, 4, going to call that B. Now understand, I'm pretending that my line is going this way. Okay? Now, again, I'm going to tell you, read your graph left to right, which means I'm going to start with B. And as I go from B to A, I need to go down. So I'm going to come straight down to where I'm directly across from my A. And on my graph, what I'm going to do is I'm going to go, okay, if I start here and I come down, how many units did I come down? Well, I went 2 units, but I need to show that I went down, so down is always a negative. Then when I turned and I went straight across to the A, how far did I go? Well, from -6 to -3, that is a positive 3 units because I'm going to the right, and to go to the right is always positive. So now I want to figure my slope. Remember, it's rise over run, or it's my change in y over my change in x, and my change in my y was -2. My change in the x was 3. So my slope is 2/3. Or sorry, is -2/3. My mistake. Okay. We now need to do a quick check like we did yesterday. Remember, this is your ticket into class tomorrow. And you're going to be doing this off of the book pages. It is your turn, and that's the title of the section. Number 1 on page 65. On page 66, I want you to do number D, 2, and 3. Then there's another your turn, which is number 4 on page 67 and page 68. Numbers 1, 3, 5, and 7. These problems will mimic the notes that I have given you, so be sure to refer back to your notes. And this is your ticket into class tomorrow, so be sure to have it ready as you come in to the room, not after you get in the room. I need to see it first. Good luck.